Welcome to this week's Swarf and Chips. Right, this week is going to be of great interest to you. Reason being, the show is dedicated to our visit to the TCT show at the NEC last week. Not just another show, nope, no way. This is focused on additive manufacturing, 3D printing, design and engineering technology, but modern technology that's happening here and now. And you will be seeing lots of extraordinary parts during the show. And an ooh la la cycle time challenge, but right at the end of the show. So Mark speaks with Sodi-tech regarding their 3D metal printing and milling machine. He's also been very busy talking to Measurement Solutions, who represent Creaform here in the UK, talking low-cost educational scanners. Joe talks with MarkForged about their 3D metal printers and the huge variety. I'm talking a really long list of materials that they work with. We talked to Trumpf, XYZ, the Carfulan Group, and finally Matsuura about their additive manufacturing solutions, all coming up in today's great Swarf and Chips. So, gents, the magazine, a great success.
Brilliant, yes. Hit desks about 2 weeks ago now. Really good read though, isn't it?
It's fantastic. 90% of the editorial is exclusive to the magazine, MTD, which is great.
We've had some really good reports from it as well, haven't we?
Yeah, and if you haven't got a copy, then you can obviously get one. You can contact us at inquiries@mtdcnc.com and get one in the post.
Okay, we've got a brilliant show lined ahead, but you were at an event a couple of weeks ago, A&B. Have you recovered yet?
Oh, it was 30 degrees over there. Yeah. It was really warm.
And we haven't seen Joe since. He was asleep on the plane the last time we saw him.
Well, until the food came out.
No, he had the food and then.
Oh, did he? Oh, right, okay.
But then the next food, well, he probably woken up
for the food to come back out again. Speaking of excitement, our Cycle Time Challenge winner, congratulations, Tom Skabala. He guessed 52 seconds, which works out about 70 per hour, and the correct answer was
60
per hour. So congratulations. Contact us please at inquiries
@mtdcnc.com
for your Swarf and Chips goodie bag. So over to our first video where Mark, you were looking up at Chris at Sodi-tech.
Chris, we're first day at TCT at the NEC. Now this machine, the OPM 250L, it's one process machining. You sold the first one in the UK, but why are you showing this machine here?
We're just trying to generate more interest really in the product. Yeah, we have got a new customer on board now down in the south of England, Cable First, who are here also on the show with us today. They're going to act as a bureau service for Sodick, so they're going to be doing some work. There's a lot of customers come on the stand who want parts making. We're not really interested in making the parts for people, we're interested ultimately in selling the machine. So they're here as a technical partner today, just picking up inquiries for bureau work. The reason we're here is just to try and generate more interest in the product itself, just to see if we can get more customers on board and build on the success that we had with Cable First.
And what makes this machine different from what else is in this hall?
Well, as far as I know, there's only one other hybrid manufacturer here, and they haven't got a machine on stand, so we're just basically here showing the machine off. This is obviously powder bed machining with milling as well. It gives the ability to create conformal cooling and parts that come off the machine finished, so that they can just be parted off and put directly into the moulding machine, and you can mould directly from them. So it's a little bit different to everybody else that's here.
And is it a benefit to have Cable First here, bearing in mind they've got the machine, they obviously know how to use it, but they're offering a service to other third parties?
Yeah, exactly. I think it has been good actually, because as I say, a lot of people come on stand, they're not all necessarily interested in buying a machine, but they are all interested in the technology, and Cable First have been a good partner here, just to talk about the reasons why they've invested in the machine, and obviously showing some of their nice sample pieces as well. And obviously people are coming on talking to them initially, talking about bureau work, but then they might have an interest in buying a machine as well. So we're just acting, it's a really nice partnership actually, we're just kind of feeding off each other.
And any engineers that haven't made it to TCT, what message would you give to them in reference to looking at the machine?
Yeah, come and have a look. It's brand new technology. It's really exciting. We honestly think it's the future of manufacturing. The industry itself is going vertical. In the last 12 months, everything's really picked up in the additive market, and everybody honestly believes it's the future. So yeah, come and have a look.
Talking about exciting things, your new factory's been built.
It has. Yeah, it started now. I think the completion date's going to be March 2019. and then there'll be a big formal opening a bit later in the year, maybe June or July. And there's plans there for manufacturing and assembly as well. Brand new showroom, 45,000 square feet, so a nice big facility. And yeah, exciting times.
Well, good to hear, but also good luck on your second day at TCT.
Thank you, Mark. Thank you, guys.
So that's quite an interesting combination to use them as a bureau. So talk us through this really quickly.
Well,
yeah, he's a big guy.
He is.
I have to look up to him.
He is. He's a unit, as they would say.
Lovely guy as well. The lovely thing about Sodick is that, you know, they're very well known for their EDM machines, but obviously with additive manufacturing, it's a big thing in a lots of machine tool capacities now. But I went down to Cable First, which bought the first one, and they're acting like a bureau because they've got capacity. And the actual video is on MTD, which I've done at Cable First, but it's a fantastic product because it's adding, subtracting, as in milling as well at the same time.
This is the technology here, so innovative. I mean, metal printing has been around for many years now, and this subtractive element to go with it basically means that you've got that one-hit machining process, which I think there's only two machines like this around the world.
There is, yep.
It's fascinating, and people will go to Cable First, won't they? See the products, and eventually, when they gain confidence,
but Cable First are an OEM, from what I gather, aren't they? They make their own product.
Yeah.
And what I like about this technology here is you see it layers up. It's the additive. It's making a layer, then it's subtracting. Then it's so it's machining around what's been printed. Then it's printing again. Then machining. Sort of 10 micron layers. It's fascinating.
And this is why I said this show was so astounding, because there is new technology that is happening that could have been a bit far-fetched in our eyes, and now it's actually happening here and now. Right, next video is yourself, Paul, Carfulan Group. What I found was you astounded me by me watching it, because when he was talking about materials, you were like, wow. You know what? Take a look.
Rob, we're on the SYS stand here. We've got the Stratasys 3D printer here. But what I want to know is about the applications that we've got here that you're going to tell us about. Firstly, let's start with this one here. What's different? What's new?
Okay, so this is a new material. It's nylon 12 carbon filled. So the focus for this particular material is metal replacement parts. This particular material has got a low CTE, and so in traditional methods where people are producing jigs and fixtures or a low volume metal part for a machine or something like that, it can be quite costly and take a lot of time to actually produce a metal component. This material here has got the stiffness and strength to actually replace those metal parts and allow you to get those parts quicker and more cost effective.
Are you seeing people printing like this then? Is that happening? Is it frequent?
It's happening today. So I've got a customer at the minute, a packaging customer, who's actually producing parts for their machines in this particular material that go out into field.
So around the show there's lots of people trying to push 3D metal printers, but what we're saying here is we're kind of changing the mindset and going from metal to a different material, aren't we?
Exactly, and we would say, does it really need to be metal? You know, when you've got the material properties of some of these polymers now that we have, does it really need to be metal when we can make it lighter? You can make your robots move quicker, we can ship things cheaper because they're lighter, so, you know, polymers might still be an option for you.
Okay, on a different tangent here, tell us then about what we have here.
So this particular material is the Antero 800, and this material is a very highly chemically resistant material. And so for aerospace customers, oil and gas customers, it can resist MEK, it can resist Skydrol, so a lot of those sort of chemicals that are quite nasty fluids, this can be used potentially again in the jigs and fixtures world or potentially end-use part world.
And how hard would it be to get the approval for something like this to actually go on an aircraft?
So Stratasys have worked with a lot of the OEMs to actually gain approval for some of the materials. So the Ultem 9085 is a particular material that can be used now in aerospace. They're doing a lot of work in the rail industry at the moment to actually find approvals for materials there as well. So I'm not going to lie, it's going to take time for people to get those approvals, but it's starting to happen now, and you'll see these parts being in use in end use.
Fantastic, thank you very much, Rob.
Cheers.
But you were astounded, weren't you? But I think you know, we were obviously speaking about it. You were fascinated by the technology at TCT, weren't you?
Well, before, Stratasys are one of the biggest manufacturers of additive machines. Absolutely fantastic, and the type of products they're actually making and the materials is far outweighs a lot of other manufacturers.
Oh, really?
And this is all about heat resistant. This is an aerospace part that they're basically trying to get. It's a critical part on an aircraft which is made out of metallics, and what they're saying now is you can actually make this out of plastics. Well, that's what they're looking to do. So, and then this as well, it's all about the strength and integrity of the parts. They're trying to replace components that are made in different materials, in newer materials, to make them lighter and also more cost effective.
I just find it fascinating. You know, we're talking about metals all the time, and now we're just bringing in something so new, so different. Are people going to have a little bit of nervousness in the industry?
For me, one of the things is we talk a lot about the potential. Like a lot of these parts, they're saying, yeah, this particular part here, potentially it could be used on an aircraft. But you're thinking, okay, well, when does the potential become reality? Because I want to see these things as critical parts. What's the approval process? How many years is it going to take? It's all right saying, you're the fastest cyclist in the world, but he's got to prove it, and yet he's yet to do that.
I'm not. Okay, no, but it is so interesting in the industry.
Yeah.
Right, still to come, Joe talks 3D metal printing and composite printing with MarkForged. Paul talks with Trumpf about their laser additive manufacturing solution and the cycle time challenge right at the end of the show on the Champs-Élysées. But over to Joe, who's talking materials with MarkForged.
So John, we're here at TCT 2018 on the MarkForged stand. How's the show been?
It's been great. We're here showing off all of the parts that we make. We've got two new, generally new to the industry processes of additively manufacturing parts. That's composites, which we do with a continuous strand of fiber, carbon fiber to reinforce the part, and metal printing. And because those add up to really strong parts, there's a lot of interest from different people who in the past couldn't make a part that was strong enough to be used in end applications on a 3D printer, so lots of interest.
We actually went to the launch of the Metal X in the UK. It's a HK3D. And what I like about it, the Metal X is brand new, your first entry into metal printing. You've got a lot of experience on the other products.
Yeah, so we're building in each new product that we do on the history of what we've learned so far. So it uses a lot of the same platform that we build into the composites machines, similar print system, similar gantry system, and so that helps us get to a state of reliability faster than you typically would in a design cycle. So it's really kind of our 5th generation machine, even though it's our first metal printer.
So, and what's next for MarkForged?
Well, we don't disclose too much about the upcoming roadmap, but I think in the near term you'll see us ship a lot more metals on the metal printer, open up new settings, advanced settings for various things that you might want in terms of building your parts with specific geometries and flexibilities. And then, of course, we're always working on new technologies, which I'm not going to announce today, but they're exciting. I'm very excited about our roadmap, and it's a very interesting time in the metal printing space. I think there's going to be a lot of development in the next few years.
What fascinates me is the list of materials that they're going through.
This is an incredible machine. I mean, metal printing has been about for many, many years, but everybody's looking to take it beyond the new boundaries. So this is about getting stronger parts, making them faster, out of different materials, but changing the materials quicker as well. And I think they've cracked it.
And it's not just the machines they've got are for composites as well. And I've been in the composites market for a long time with the aerospace market, and it's amazing that suddenly it's just not about metals, is it?
No, and I think HK3D are really onto a good thing here. I can see this such a broad range of industries, especially the changing the materials quickly. You're reducing all those barriers to entry. Also, the health and safety factors are a lot less. So I just think that this is a great opportunity to get into 3D printing at a very low cost as well. You're talking about £110,000 for some of the machines that they're supplying, which we've focused on before, but groundbreaking.
Well, they've done a swarfandchips, and we interviewed them a week or so ago, so quite interesting, and definitely a company that's really growing now.
And I like the guy in the background there as well.
Yeah,
it looks like
who is he?
Nice t-shirt.
Oh dear. So, Paul, you visited Trumpf, didn't you? Finding out how to stay hot this winter, again with another fascinating part. So let's go see.
This is a fantastic one. I'm on the Trumpf stand here. Now, Tom, I want to know about this part that you, maybe not printing here today, but you use your machines to print.
Yeah, sure. This is a real part. It's part of a combi boiler, and it's a really complex geometry, but where we see this benefiting is in the middle we have the gas burning, and on the outside we can have the water jacket, and what that enables is a really efficient system because we're not allowing the heat to escape from the centre. That gives us the really good efficiency. The downside is the real complex geometry, however on a true print that makes no problem for us, so we're able to create that part.
And I think this is a brilliant example of additive manufacturing, isn't it, and how you've not been... you've redesigned the whole way you need a component to work to get the best out of it. And I can also think that this is also designed around the fact that you can touch the outsides, the extremities of it, and obviously there's no heat then because it's kept internally as well and water cooled on the outside.
Absolutely, that's exactly right, and we have to We have to go back to the design stage when we're thinking of 3D printing. If we're just going to create a standard part, then we're not necessarily going to win. So we go back to the design stage, we create the part with 3D printing in mind, complexity is no big deal, and this is a perfect example of that.
We do things called a cycle time challenge on Swarf and Chips, but I'm actually going to tell you the cycle time on this. It's actually 80 to 100 hours build time to make this from start to finish, which is quite incredible, really. A great example of how 3D printing, is kind of taken over things in the re-engineering world. Trumpf, just 30 seconds on the machines that you supply here from Trumpf.
Yeah, we've got 2 machines available today in our range. Will be 3 machines next year. The TruePrint 1000, great little machine for R&D, development, high value materials, working area 100 millimeters by 100 millimeters. Better, higher production machine is the TruePrint 3000, 300 millimeters by 400 millimeters. Has the detachable cylinders, so depacking can be done separately. Coming next year, we'll have the TruePrint 5000, same capacity as the 3000, but with multi-laser, also to give us the faster production rates too.
Oh, what a lovely part.
Beautiful, isn't it? When you look at what's gone into the creation of that, this is a classic case of redesigning a component. As he was saying before, I mean, I've never seen a combi burner, other than this first one, but I can imagine that it is nowhere near as, call it, as you said, nice looking. But this is about efficiency. These channels obviously here can conduct the water.
Incredible, isn't it?
It keeps the water heated. It also means that on the outsides of the part, it's not getting hot. But the whole principle here is about re-engineering, rethinking from the ground up. 80 odd hours, I think, as I said to me.
And yet again, it's another company that is very well known in other industries like the sheet metal sector with their laser products. But
they were the first. They were one of the first. Well, in 2005, they developed their first metal printer. Trumpf did, but it was too early. So they had one, and they basically then said, okay, well, we'll park this technology, and we'll come back to it when it becomes more in demand, which it is now. They've got a new machine next year, as he said, and I can imagine Trumpf have got the infrastructure and the support to be able to support companies.
I have a request for you. There's too many different technologies here. Could you maybe do some educational videos? I think you'd probably agree.
I think it's a good point, but learned so much this week at the TCT show. It was incredible, really. I mean, one of the things that I picked up as well is that NASA are actually starting to use 3D printers now in space. So they're essentially taking robots into space and then taking the materials up, and they can be building infrastructure, they can be building buildings. Instead of taking the buildings up, they're basically printing them.
Well, we are certainly
We're going video.
forward.
Yes, we'll have to take the video when we get up there to take. Yeah.
Oh goodness! Right, okay. Still to come on the show, Mark is talking 3D scanning technology for under £10,000 with Creaform, who represent Measurement Solutions here in the UK. But first, here's Gio at XYZ talking about how they 3D print parts for their very own machines.
John, this is an absolutely fantastic application. I really like the way that you've designed this component. Now, tell the viewers, what is it and what is it for?
So we sell a lot of VMCs, obviously, and we have a model called an 1100 HD. It's a box guide machine, very heavy duty. It has 2 swarf augers running through the bottom, evacuate the swarf. We were paying for a bracket to be made to hold down the swarf augers, and paying something in the region of £45 per part. Through design, we decided to 3D print it. So this cost us around £20. It's a lot lighter. Obviously, the life of a swarf auger is quite a hostile environment, so the material's up to being submersed, and yeah, it's more than up to the task.
So this is absolutely great, really. You know, you're 3D printing parts for your CNC machines in a more cost-effective way. It's brilliant.
Well, absolutely. I mean, we go out to customers and we preach the fact that 3D is the future, and the proof's in the pudding. You know, this is the first part that we've done and put into production. And I'm sure it won't be the last. We'll be looking at a few others as well.
And I'm sure that the bracket that you had before probably didn't even look like this. This actual bracket could not be machined on a CNC. It's impossible. You've got a triangular hole that goes through round a corner. This is impossible to do. So this has been designed for the purpose, for the application.
Oh, absolutely. And to get the best out of the machine, you really should design for 3D. the machine comes with consumables. You're paying for powders, and if you haven't got to use any of the powders or the agents, you're going to save money. So yeah, through the design, the triangular design you built, you've got the strength and fit for purpose.
So they have got the confidence, haven't they, to make a part for their own machine?
Yeah, it's what a way of kind of presenting the features. You're confident enough with the technology to make a component that is going to go on another product that you're going to sell. So I think that's really what XYZ have come up with here. They're a reseller for the HP machine.
What a brand!
What a brand, and also a machine that is also taking 3D printing into production. And that's what this machine is about. You fill the drum up, call it. It runs for 10 hours and it'll print as many parts as you can fit in that drum in a 10-hour period. And here, obviously, the materials and the way it prints shows that you get the strength in those components to be able to replace metallic parts. I think I would probably say a big thing about TCT is the fact that a lot of the things I was seeing is about how you can not just re-engineer, but not necessarily have to use metal components in things. You can use different materials that might be cheaper, lighter, and essentially more effective than using a metal.
And yet again, a very iconic machine tool company in the UK, XYZ, going down this route, big portfolio for their customers.
And they've already sold machines into the UK market, which we heard about, which was, they've only been representing them for a matter of months, really.
Okay, brilliant. Now, Mark, you've got some interesting facts, haven't you, coming up about measurement solutions?
If you read it.
Well, all I would say is don't listen to me, watch the video.
Mark, you're responsible for sales across Europe for Creaform. We've caught you here at the TCT show at the NEC. Now, Measurement Solutions, your distributor in the UK, they've been very, very successful with selling MetraScan and also the HandyScan. However, a brand new product. Tell us more.
Yeah, so we are launching actually the new Academia scanner, which is a scanner dedicated to the educational market, because MSL has been established here in the UK selling the Creaform solution into the metrology market, targeting industrial people. And we know that there is a real need in the educational world for an affordable 3D scanning technology to actually put this Creaform technology into the classroom for students. And so far, the high-end technology was a bit too expensive, and when we were putting all the things together, meaning like the scanner, the software, it was not affordable for the academic people. So we came this year, last April, with the Academia package. What it is, it's a portable white light scanner, which is based from an existing technology of Creaform, which is called the GoScan. The GoScan we are selling to the industry, and this specific Academia is made for the educational people. So this is basically, I will start using it. This is a white light scanner, which is truly portable, very easy to use. So the concept is to have a low-cost scanner to be put in a classroom. We talk about a budget of roughly 10k pounds. We also have like an offer with multi-scanners, and this comes with 50 software license for the student to practice with reverse engineering, but also with quality control. So the reason for Creaform of releasing this technology on the educational market is first to make the Creaform technology accessible for students, for teachers, but it aims also for our future customer to be trained on Creaform technology and this very innovative technology by having students learning today the concept of 3D scanning, the concept of reverse engineering and quality control, and later they will apply that in the industry. So we are also, we trust that the student of today will be the user of tomorrow.
Well, I think this is a fantastic innovation for schools and colleges, universities. Good luck with the product in the UK.
Thank you very much. It's a pleasure.
Under £10,000.
Well, before I talk about the product, Measurement Solutions are one of the best resellers in Europe for Creaform with the Handy Scan and also the Metro Scan. I think they sell around about 40 or 50 different items with the software, and it's a fantastic product. It really is.
I think with this is the good thing about today's show is we're not only talking about the printers, but we're talking about the metrology that goes with it as well, because 3D printing isn't just about making the part, is it?
You still have to measure
everything that goes around it, the consumables, the metrology. This, to me, the thing that stands out, £10,000. Okay, he talks about it going into an educational market.
That's where it's aimed at. It's very much.
But is it not good for the end user market?
That's what I was thinking.
Well, they want to brand. They want to sort of brand not only Creaform at universities, academies, etc., but get them using it rather than just a CMM.
Well, they want to bring the youth up using their products, so when they go into the factory, they're thinking,
this
name, we're going to buy this particular product. So he looks like me as well, doesn't he?
No.
Well, he's not French. Well, actually, he is French or not.
Yeah, you're close to being French.
He's my doppelganger.
No. Anyway, the last video at TCT, Paul, you managed to grab the guys at Matsuura, so let's take a look.
Cycle time challenge for this week from TCT. Joe, what's the story behind what we have here?
So this is the Eiffel Tower, as you can probably tell.
Oh, it's a Blackpool Tower.
Yeah, well, that's what I'm telling everyone in the UK. But it is actually the Eiffel Tower. Basically, there was an additive manufacturing competition, and also we sold Lumex 60 into France. So we sort of combined the two. So it's part of a competition and also almost like a gift to one of our customers.
Okay, what have you made it out of?
So it's made of maraging steel. The thing we're trying to show is that we can also machine as well as build.
And that's the sketch here, isn't it? It's the fact that this is done on the Lumex machine, which is an additive machine, but obviously it's got the subtractive element to it as well, so you can build the part and then machine it. Yep. Can you machine it to a tight tolerance, Joe?
Yeah, so over the build area we can be within plus or minus 25 micron. If you sort of localize it, so the machine's actually accurate to plus or minus 2 microns. If you localize it, you probably get it down to plus or minus 5 micron on smaller parts.
And just before we conclude this, what is the market for this Lumex machine? Where did Matsuura have the most of their success in selling this additive and subtractive machine?
Okay, so the main focus was mold manufacture. We developed it with Panasonic in Japan. Now people are realizing, the capability for part manufacture with this machine. It allows you to machine and 3D print in one platform.
Okay, great stuff. So how long did this take to not only print, but then obviously machine to get the finished part that we've got here? That's this week Cycle Time Challenge.
This is what I said, extraordinary parts in the show. Don't forget, for yourself, you too can get involved by guessing the Cycle Time Challenge in the comments box below. We announced the winner from last week, and we'll do the same next week on Gio's show.
And don't forget, this was actually made on one of their Lumex machines, which again is an additive and a subtractive machine. So it layers up, I think it's about 10 microns, then it machines, layers up 10 microns, machining again, additive, subtractive. That's the technology here. How long did it take to make that? Well, I reckon you're talking, I would say probably 2 days. So I'd probably 20 hours.
14 hours, I like it. All right, okay then, but it's not up to you. You can't win anyway. So please do enter, and you can yourself win your Swarf and Chips goodie bag. So don't forget the 100th Swarf and Chips is coming up. It's going to be a brilliant show. Gio's organising the next show next week, so that will be good fun, won't it? Mark's heading out to a secret location. We always say he's our international man of mystery. Don't forget to like, comment and subscribe. If you want to watch any previous episodes, click on the links here. And as we always say, keep those spindles turning.